and welcome. My name is Christina, and I work here with Centra. This is the third TypeScript that we've been organizing, and again, thank you all for coming. If you've been here in the previous ones, you probably will know some information already, but I'm going to go through some announcements again for anybody that is here for the first time or forgot. If you want, there's plenty of beer that is sponsored by Centra. So anytime, please feel free to get up and go and grab one if you want. Of course, if there's a speech happening, please be a little bit quiet and respect the speaker. And if you need to go to the bathroom, it's just at the left over there at the back, close to the kitchen area. And if you have any questions, please feel free to come to me or any of the other organizers that are wearing a lanyard. Some of them are in disguise, so you can play treasure hunt or whatever with them, or come to me and I'll point you to them. And yeah, so today we're going to have two different talks: functional reactive nature of Node.js in Marble.js and functional composition with static types. I should probably tell you that I work in support, so I don't code, so I don't know anything about these things. So you can ask me questions. I'm just going to nod and try to find the right person to get your answers, essentially. But yeah. The event is blessed by, sponsored by, co-hosted, whatever you want to call it, by Centra, Young, Skilled, and Ingrid that are sitting in our house in this building. Come in, it's fine. Yeah, another one of the meetups that is organized by Ingrid is happening on April 11th, so feel free to also come to this. It's going to be at the same building. At 7, of course, so go Wrocław. I don't know much about it, but I guess you can Google it and find out yourselves. So good, right? And you can also sign up and, well, join our Slack community, Wrocław TypeScript. You can also find it within this beautiful TypeScript.community website. You can join the community here and actually join the meetup as well and find more information. And if you want to become a speaker, oh, quickly, 1 second. The Slack thing is here as well, so easier to find. If you want to become a speaker, you can click here. If you have an idea and you also want to talk about it, you can get started on that thing, propose it, and then we're going to get back to you and talk with you about it, essentially. If you have an idea but you don't like public speaking and you don't want to deal with it, just put it in here and hopefully somebody else will be keen to take it over. If you go to projects and under community, you can see all the different topics in here. You can also upvote them. So just have a look, essentially. And yeah, let's go back to our presentation. Another cool thing that is going to happen today is the book, this beautiful book. We have a giveaway. Best question is going to get this, so ask questions and be quick, because of course if you're going to raise your hand and we're going to run out of time, sorry. Yeah, pretty much straightforward. And the judges are going to be the speakers, essentially, so you can blame them, sorry, if you didn't get it. Also, if you're going to leave earlier, I don't know, either come speak to us if you have asked the question and you want to somehow secure the book. Give us your details or something, because we're not going to be able to get you somehow. And if you're going to message us after and be like, I won it, yeah, it was me, we're not going to believe you, I'm sorry. Yeah, and last thing, the event is being recorded. So this, Piotr, right? Yes, he's recording it. We were not sure if we should do it or not, but eventually we thought, let's go for it, because you know, it's a local event. We wanted to make sure that everybody's comfortable and things like this, but at the end of the day, it doesn't harm anybody, and you can always rewatch them, right, if they're recorded. So that's another cool thing. And last thing that I should probably mention, it's my birthday today, so please be kind to me. I don't want to be like, yeah, very, very quick note. So if I say something weird, just, yeah, let it go, basically, because it's my birthday. Yeah, cool. So, oh, another thing, last thing. We're having a lot of different positions open for jobs, essentially. If you want to get hired, then please get on the websites of the co-hosters and apply. We are looking for a support person as well, so if you want to work with me, apply. And yeah, we can start probably with the first talk. For 4 years software developer at Boulder. I hope that was right. Yep, Boulder. Marble.js, author, functional reactive hipster, a pedant with a little of OCD. There are rumors that he can talk over and over again about only 3 things: functional programming, reactive functional programming, and Marble.js. Over to you.
Give me a second. First slide. So, I'm Józef. I'm senior JavaScript developer, and I taught everything I know about my company, Boulder. And one thing to mention, you can count how many times I will say a monad during this talk. So after the talk, you can tell me the exact number, because I'm very curious of it. And let's talk about functional programming. So, functional programming isn't something new, you know, and definitely it's not a trend that which just born. If we look back, we can find roots at early 30s of 20th century, when someone very clever laid down theoretical basis of current functional programming thanks to something like the lambda calculus. And the most popular pure functional programming language was invented about end of 80s, and it was, of course, who knows, Haskell. And for many freaks, it's like a holy grail of pure functional programming, and it's a big representative of this paradigm. And many people think that when you try to learn functional programming, at some point you should know this language. And somehow that's true. And this sign, of course, it is not an announcement of the third half-life, so sorry about that. Sorry. But it is just a lambda sign. In lambda calculus, this sign represents a function which is unnamed, But for many programmers, it equals somehow to the functional programming. Oh, come on. And when we look at the functional programming, it looks like a hell. So you can see some weird words, weird formulas, some axioms, definitions, equations, where for many people it looks definitely like a math. And this topic, as you can see, is not simple, especially when we have to face with those different, very weird terms like functor, bifunctor, profunctor, monoid, setoid, and of course the famous one, the monad. And in order to know what is functional programming, you don't have to know what is the functor, you don't have to know that it maps between different categories. And the functional programming is not only about the category theory, which is a branch of math with different type of usage on which the pure functional programming is based on. So in order to work fluently and work easy in the functional programming world, you don't have to know what is monad. And I will try to somehow shortly describe 5 pillars that the practical functional programming is based on. So let's start from the first one, which are pure functions. So they are just functions without side effects. And what is side effect? It can be anything that has a noticeable interaction with the outside world. So for example, let's say that it can be a database access, some logging, file system access, networking, database, and etc., etc. And the pure functions are always doing the one thing, the same stuff inside, and for the given set of parameters, they output the same value every time. And in the practice, it looks very simple, and at the beginning, it can look like this, but in the practice, it's not. And what it gives us, for sure, the predictability. We know what will be return value of our functions, and it is easy to test. And also, connected with pure functions, we have something like referential transparency. And the responsibility of function is to return a value. So if the function always returns some value, then we can easily replace our function invocation with this return value, and our program should notice this and should work easily without any problems. Also, we have the immutability, so we should forget about the variables, use only consts. We shouldn't mutate our object, our data structures. We should work on immutable data structures, and of course, when we would like to mutate something or change in our structures, just copy this and change this on the copy, not on this thing that we would like to mutate. So we will by doing this, we will avoid many obstacles and errors in our code. So it's very important. And of course, functional programming is only about functions, so we should treat our functions like a first-class citizen, which means that we should treat like everything else in our code, so like a number, strings, object, etc. So we can put it inside our arrays, you can assign them to constants, you can pass an argument to, you can pass this function as an argument to other function, and you can return a function in another function, which is sometimes called, or very often called, as a carrying, like in the example in the slide. And of course, very important thing that many functional programmers can forget, we should be aware that the recursion is the very important thing for dealing with for loops, because in pure functional languages we don't have any for loops. So every time we would like to iterate through the data collection, you should use a recursion to reach your goal, which means that the function evokes itself inside the function definition. So for example, if you would like to get a length of your collection, you should operate over the head of your collection and the tail of your collection. The head, which means the first element. So you are passing the tail to your recursive invocation, and then you can iterate through it. So many people are finally hearing about functional programming again. So thanks to the libraries like NGRX in case of Angular, Redux of course, React also, RxJS, Lambda, Lodash, or FPTS, programmers are able to test functional programming inside a very weird environment like is the JavaScript. So, the reactive programming. You might also think that reactive programming is something new, but you can find its roots at the early of 70s, so that's not new. And reactive programming is basically a philosophy which is based on events, especially events passing over time. So it assumes that elements of your app have to react accordingly to users, for example, the user interactions, some server responses, errors, events inside your code. So it allows you to achieve a loosely coupled program thanks to the data streams that exchange the data using parallel streams. And the reactive paradigm can be implemented in many different ways. So for example, very popular framework like Vue.js implements its own way of dealing with reactivity, which is not exactly the same in case of the RxJS library, but it has some similarities. The interesting fact is that the best example of reactivity are spreadsheets. So you probably work with Excel or something similar, and this is the example of reactive mechanism. So you change some value in one cell, and all cells are reacting accordingly to that change. So in JavaScript world, the most dominant and popular implementation of reactive paradigm is RxJS. And this is a library, it is not a framework. And it defines a reactive extension for JavaScript world, and also add some functional sugar to it. And when we look at the ArcGIS API, the story can be similar to functional programming. So we have many word terms like, for example, merge map, concat map, switch map. What's the difference between them? This is a good question for the recruitment task. So it could be this is very word library, but this is really powerful. But in reality, reactive programming is not only about using those operators together, how you can apply them together, and no, that's not the reactive programming. The reactive programming is basically just asynchronous, dealing with asynchronous data streams. And this is a very short definition proposed by Andrew Staltz, and it tells everything about the functional reactive programming. So we have one value that occurs at one point of the time, and then we have another value at some point of the time, etc. And what you can do with those values passing over time in the streams, you can do whatever you want. You can do whatever you imagine. You can, for example, map them, you can filter them, you can buffer them, you can transform them to anything, to something else, and you can combine many different streams together. So doors are open, you can do anything. And of course, ArcGIS adds something like observable. And this is a cool abstraction, more powerful abstraction for dealing with asynchronous problem, much more powerful than our typical promises. So you can return a value one time in promises. On the other hand, in observable, you can return multiple values over time. Observables are lazy, so they are working only when you subscribe to them, and promises are not lazy, they are eager. And another thing that is very important to observables, you can cancel them. So you can't do this in promises, that's obvious. And the very interesting thing is that regardless of its source, you can use it for many different things. For example, you can use it for DOM elements, events, HTTP requests, timers, etc. And you can also process very large amount of data in a much more performant way than the typical methods that you can observe in the arrays. So in functional programming, they are called as transducers, but that's not a talk about transducers. We are talking about functional reactive programming. And functional reactive programming is a combination of those two paradigms together, and many people confuses this because reactive programming is not functional reactive programming. So this is not the same thing. But we are talking here about this one. And let's start about talking about Marble.js. And this is a functional reactive Node.js framework for building server-side applications. That's why I talk so much about functional and reactive programming in separation. And this framework is based on ArcGIS library, and it uses it like a toolkit for dealing with the asynchronous stuff. And from the very beginning, it is targeted to TypeScript user. That's why I'm here. And since version 2.0, it acts like a framework. So at the very beginning, when I released this thing, it was like a small middleware or library for dealing with the asynchronous stuff in HTTP protocol, like REST APIs using the streams. And after some time, it grows, and then since version 2.0, it is a fully fledged framework. And what you can do with this framework, you can build REST event-based APIs with ease, of course, because this is the best place for dealing with asynchronous stuff. And of course, this is fully open source project, and it is a totally company independent project, which was born because I was bored during my May vacations, and I did some very simple proof of concept, and after some time, it became a framework. And a few days ago, you probably can see this on the slide, we reached the 1,000 stars on the GitHub, so we have something to celebrate. But the interesting stuff is that during the first initial release of this library at this time, we reached above 800 stars during the first month of its release. And we got a big shot of support from Ben Lesh, which is a core contributor or the maintainer of the RxJS library. And for some time, for probably 3 days, we were the most popular, most trending TypeScript repository on the GitHub. So that was cool. But let's talk about the characteristics of Marble.js. So, because we are using RxJS like a toolkit for everything that you can see in the Marble.js API. If you look at Marble API, you will notice that RxJS is used there extensively. So it is a functional reactive framework, and that's why RxJS is a first-class citizen here. And many people ask me, Joseph, why do we need RxJS for single event nature of our HTTP? Because we have one request that is passing over time. Where is this reactivity? And usually RxJS is presented as a toolkit for dealing with complex UI mechanics like, for example, drag and drop or multiple events passing over time, so you can combine them together and do some crazy stuff with this. And yeah, that's the best usage of reactive paradigm, but as I previously mentioned, it can be used for many different aspects, for example, like Hammer for expressing asynchronous flow. So it can be also used as a replacement for the very basic promises. And it has a monadic manner. So the pure functional languages like, for example, Haskell expresses side effects such as I/O and other stateful computation using monadic actions. So RxJS observable is also a monad, the same as promise. So promise is also a monad, funny story. Using its monadic nature, we can map I/O computation in a much easier way than, for example, the promise. So we can map the I/O operations over effects, chain them together to bring other sequences of operations, and it's a much powerful and feature-rich monad than the I/O that implements the basic abstract interface, as well as a ton of additional functionalities that you can do with RxJS for manipulating sequences of events passing over time. And the specific aspect of Marble.js states that everything that you can see in this library is treated like a stream. It can be an endpoint handler, it can be a middleware, it can be a HTTP server event, or even it can be a WebSocket handler. But Marble.js, because everything is treated exactly the same, everything is a function that takes a input observable, the input stream, and transform it to another output stream with a different form. As a result, it can be generalized to some abstraction that we can use in many areas. And Marble.js defines this building block as an effect. In general, it is an abstraction over a function that I described previously, and it can be applied in many different areas. So for example, we can have a specialized effect for dealing with HTTP, for example, REST routes for dealing with HTTP middlewares, defining the HTTP server, events, handlers, and we can also apply this thing to WebSockets. So, because Marble.js is based on functional programming, also it has some aspects of the pure functional programming, which means that Marble.js effects are referential transparent, which means that each effect at the end of this computation of each of transformation should be mapped to some object. So in case of HTTP effect, it can be mapped to the object with a status 200 body, some body with the string hello world, or some headers. So for example, it can be also similar for WebSockets handlers, where you can map your input events to some output events as a result, which should be sent to the client at the end. And because this is a functional framework, everything is treated as a function. So you can define a HTTP route which is built only using pure functions, where we can have a pipe which can match for some path, the type. We can apply some middlewares, we can apply some effects, and we can apply other middlewares inside, and then we can do some other crazy stuff that we can do with RxJS. But of course, everything here is a function, but there are some places where you can use classes, for example, for dealing with errors. But they also can be replaced with functions. And it is not only used for basic HTTP protocol. As you probably noticed, it can be also used for WebSockets. And that's a very cool example to show. So I would like to build some calculator. And how can we build a calculator using RxJS and WebSockets? So let's say we have two effects, one which is targeting the add event, second which is targeting the sum event. And what can we do with them? The add event is buffering each add event that is coming to it, and when we reach the sum event, which is our effect terminator, we are flashing our buffer and we are reducing it to one value, and at the end we are mapping it to another event which can have a sum. And how does it work? So let's say we are passing event add with value 7 and another event add with value 1, and we are passing our terminator, which is our event with sum, and the response is very obvious, very simple math, which returns 8 to our client. And this is a very cool example because it shows the power that we can do with Marble.js combined together with RxJS. So the reactivity shows its close at this example. But Marble.js has pure functional programming patterns in mind, and it means that it has the dependency injection mechanism since version 2.0. So for example, we can define some dependencies that we would like to bind to our server, and we can for example, bind to this server some currently running WebSocket listener. And what we can do with this bond dependency, we can use it in our effects, for example, inside our HTTP effects. So we are asking our context, we are getting this value where all types are properly inferred, thanks to TypeScript, of course. And we can, for example, send a broadcast response with the type some event and the payload data to our clients that are subscribing to this event. So, for example, in case that we are adding some data to our database, we can notify our currently listening clients that something happened, and we have another thing in our collection, for example. And also, type safety is very important since version 2.0. So it was our main goal to improve it. So let's say we have our request, our route, HTTP route, and we have some path for users, the type post, and we are getting the body from this request. And at this point, we don't know really what is the type of our body, what's inside of this. Probably we are not sure if our client sent the proper request body to our server. We are not sure if everything is properly defined. So, thanks to IOTS library, which is very cool integrated inside Marble middleware, we can define our schema. So let's say we have a user schema with ID string, name, age, number, and some roles, where we have a limited set of literals that the user can have. So for example, it can have admin role, quest, one of them, or nothing. And we can apply those schema to our request validator, and we can validate our request. When some request appears, it can throw an error or just pass our request to the next function below. And because this is a TypeScript, this is IOTS library, which is very powerful, we can infer our request body using this validator, and we can achieve a type safety of our requests. For example, we can apply it not only for request bodies, but for example for parameters, query parameters, headers, or for example in case of WebSockets for our events payloads. So that's cool. Also, you probably noticed that we are building our HTTP routes using pure functions with the pipe function and some operators. But there is one alarm. What if the user will put another match type, for example, between use operator? We should see that the compiler will warn us here. So, thanks to monads, of course, and the power of indexed monads and the TypeScript, we built a totally type-safe request route builder, which has some rules inside. So it defines some rules that, for example, at the beginning we should define the path, then after the path the type. We can apply some optional number of middlewares, and then after the middlewares we should apply use effect, which is our main effect handler. So that's cool. And you can ask me, okay, Joseph, why should I care? We have many different frameworks on the market. We have our very big Nest.js framework, which breaks the records in the popularity on the GitHub, which has about 13,000 stars there. And why should I use Marble.js? Because it's easy to test. We are dealing with just pure functions. We can easily unit test our effects because every effect returns an object after it. So it is just easy. And of course, this is easy to read if you are a functional programmer. And there is a small emoji because this is very subjective for many developers, and for many other developers it can be totally mess. And it is easy to reason about because we have a linear flow from the top to the bottom, so it is easy to know what the effect handler is doing. And we can avoid confusing problems and errors in the code because it is based on functional paradigm. So using the referential transparency, the pure functions, and etc., we can be safe. And it's really too fun, and just try it. You can love it. And this is the future, man. So I believe that in the future we will build many big applications only using the functional paradigm together combined with reactive stuff. And some summing words. You can find our GitHub repository by putting Marble.js, and you can vote or add stars, and you can put an issue there if there are any problems. I will be very grateful to know if there is something not wrong. And you can reach us on the Twitter, and you can see there if there is something new in terms of the Marble.js, some cool articles or something was released, you can find there. And of course, visit docs.marblejs.com where you can find anything about Marble.js, its philosophy, its core concepts, API stuff, documentation. And of course, we also added a migration guide. So if you used Marble.js previously in the version 1.0, you can also use it. You can use this migration guide, and you can easily upgrade your app to the version 2.0. And the summing code, sometimes the elegant implementation is just a function, not a method, not a class, just a function. And believe in this quote. See you on the Mars. Thank you very much for listening to me, and thank you again.
Any questions? We will hand you the mic, so yeah. Remember the book.
Okay, so firstly, thank you for your speech. And secondly, I have a question like, have you ever heard of the concept of creating a front-end app using only functional reactive concepts you've talked about?
Yeah, there is a very cool framework that its name is Cycle.js, and its author is Understat that I mentioned during the talk. And this framework is using the reactive programming extensively, but it's not using RxJS inside, but some other implementation similar to RxJS. So everything that you can build there, you are treating everything there as a stream. So similar, for example, to React, the very rough React without JSX, you are building there everything using streams. There are some concepts like sinks and etc., but definitely Cycle.js is a good representative of reactive programming, strict reactive programming in the client side for building apps.
And it also applies to functional programming?
Yep,
okay.
Also functional.
That's all, thank you.
Thank you.
Thank you for your talk. I have a question about the. I'm not familiar with RxJS at all, JS at all, and I have a question about the pipe function type definition. Is the result, in the type sense, the result of the first argument of the function gives kind of an insight what can be passed as a second argument?
Yeah, exactly. So maybe I will go.
And if so, what are the limitations? Did you use any new features of TypeScript for that? Something like that?
Not so many, because the RxJS pipe function is totally type safe. It uses some very rough boilerplate inside, because currently TypeScript is not very well supporting the type inference inside the function composition, but in the next version probably of TypeScript 3.4, as far as I know, it will be improved. So answering to your questions, yeah, RxJS pipe will infer properly the types of our applied functions inside. So at every step of this pipe function, the type is properly inferred. So if you will apply the pipe, and for example you would like to have the results of this pipe function, you will have the proper type at the end. So it is totally type safe.
So what's the limit of the arguments?
I don't know. I heard about maybe 20 arguments, but in real world nobody's seen that.
Okay. And last question, does it influence the error messages? Because we all know that TypeScript can produce some awful error messages. I'm just curious.
No, the error messages are good, I think,
Okay.
as far as I remember.
Thank you.
Thank you.
Hi.
Hello.
So my question is, what are the plans? Do you plan on like working on future releases? Maybe what's missing, and what do you want to add to Marble.js? Well, like, do you have any roadmap?
Yeah, that's a good question, because so right now we are on early stage of 2.0, so we released it about 1 month ago, as far as I remember, and we have some plan for future releases. Of course, we would like to improve our middleware's ecosystem. And also we have some external contributors that are adding some additional stuff. For example, previously in version 2.1.0, we have a contributor that added Joy middleware for validating requests. And also we have a contributor that added middleware for dealing with cores. But regarding the roadmap, for sure in the next major release we would like to focus on the HTTP2 protocol, because it can be, I think, good applied to RxJS world, because the HTTP protocol can handle multiple responses over some, let's call it maybe subscription or some channel, let's say that. And also we would like to improve the functional programming stuff inside of this. I probably didn't mention that the Marble.js underneath is also, since version 2.0, using FPTS library, which is used for dealing with functional programming inside the TypeScript world. So we would like to somehow better integrate it together. So probably you can expect more monads inside. And regarding the code, that's probably it. For version 3, I don't know what will be after the third version, we'll see. But for sure we would like to improve our documentation, because right now I heard some words that it can be very difficult for newbies that are not so familiar with functional programming, especially combined with reactive programming. So that's probably an area where we can improve the framework and the ecosystem for newcomers. So that's the plan.
Okay, thanks. My second question is, I'm curious, how does it work? Because I haven't heard of so many Polish companies which have open source libraries, let's say popular open source libraries. So does your company support you in working on that? Can you work on that on your working hours? Do you have some other people who work on that from Boulder?
No, so this framework is totally company independent, because as I mentioned, it was born during my holidays, because I was very bored and I wanted to write something that has the RxJS for dealing with the HTTP. And currently Boulder is supporting me in terms of the promotion stuff or some other not related to the code stuff, but it is totally open source and company independent. So that's my personal project, and I would like to keep it as it is, and doesn't connect it with other companies, similar to what's doing currently in SJS.
Cool.
Anyone else?
I have a question, because you talk extensively about what is the pros of this Marble.js. I want to ask you, what do you think about the cons? Do you see any cons of your framework?
Good question, because the cons of using Marble.js is that you have to know what the functional programming is, especially combined with reactive programming. And at the beginning, when I created this framework, I know that its popularity will be limited only for the persons or the developers who knows what it is. So I was aware of this. But the cons of using Marble.js, for example, I wouldn't recommend using it for templating stuff, for example, that you can do with Express, so you can do server-side rendering. I don't think so that it could be a good candidate for this stuff. Maybe yes, I need to check that, because I didn't thought about this. And if you would like to do some event-based stuff, so for example event sourcing or CQRS, this is a good candidate. But regarding the cons, maybe server-side rendering is not a good candidate.
Okay, thank you.
Hi, I was wondering how this impact the performance, because the structures, how it's all built using observables and so on, looks a bit of complex. And I wonder, did you do any performance tests how it's performed against more common frameworks?
Yes. Yeah, I don't have any graphs that will show what's the performance of this library or this framework. I did some benchmarks during the initial release of version 1.0, and I compared it to other similar libraries or frameworks, whatever, and I tested it with comparison to Express, Fastify, yeah, and Koa and Happy, of course. And it turned out that it is faster than Express. It was our main goal during the development because we wanted to be better than faster than Express, but it is also similar in the performance to the Koa or the Fastify, and obviously it's faster than Happy. And yeah, I didn't do any benchmarks after 2.0 release, but maybe that's also a good point to look how the performance, what are the impacts after the version 2.0, if this performance is slower, lower or better. I need to check that.
Okay, sounds impressive. Thank you.
And someone in the first row had a question, right?
This is some like entertaining question. So you told at the very beginning that functional programming is all about recursion and no loops. How many times did you got Stack Overflow?
It depends on what area I should look for the Stack Overflow, but inside Marble.js there are not so many recursions as you might think, but this is a general concept of the whole functional programming. Maybe that's not so exposed in Marble.js. Maybe there are some recursive functions inside, mainly for building the static array of our HTTP rows, but there are not so many recursions inside.
Hi. I've counted the usage of the word monad in your talk. It was 7, including word monadic, and one more in QA session. So my question is, did you dare to use your Marble.js in production?
At Boulder we use it at production in one project, but I don't know so well if someone else have it on production. I heard some words from other maybe contributors or other persons that I found on the Twitter that they use it in their company. Someone use it on the production in Brazil, maybe, I don't know. He said that, but I think that the framework is still on the very early. It is very at early stage, so I wouldn't suppose that it would be on the production even after release 2.0. So right now the framework is doesn't have it's not even 1 year old, so maybe you can ask me this question in the next year. So I will try to go deeper and find some more resources and ask people if they are using it on the production, but I believe that it can be.
Thank you.
Cool. Yeah, yeah, I do have a question. If I can, I haven't seen any generics in your code. So my question is, do you have like one schema that describes all of your endpoints or something like that, so you could have end-to-end type safety? Like, how do your request handlers know what data are going to be in the request body? Is there some way to tell them about it?
So this probably not so exposed on those slides. Let's try to move back. All those HTTP effects, HTTP middleware, HTTP server, and etc. is based on the generic interface, which is the effect, which has about 3 parameters for defining our effects. So, for example, the input value, output value, the type of the second parameter that is not so exposed on those handlers, and for third parameter after that. But yeah, generics are used there, and also thanks to that generics we can have the type safety in our middleware, so our middlewares can return properly typed HTTP requests. So also HTTP requests are type safe because each request that is transformed, for example, through the middleware has its type safety, so we can define its body type, parameters type, and etc. So at the end, the output of those middlewares, the output of the HTTP request is also type safe using the generics from the HTTP request.
Cool, thank you.
Okay, thank you so much for your talk. I hope you all enjoyed it. We're going to have a quick 5 to 10 minute break. You can get more beer or food if there's any leftovers. And don't get too full because we have pizza later. And yeah, see you again in a bit.
Thank you.
I will quickly read a brief introduction for our speaker, Tomasz. And then I'll hand over and he's going to start his presentation. So, independent consultant, architect, and developer, your JavaScript world guide, speaker at European and Polish conferences, a trainer with a passion to explain how things work and avoid overcomplicated solutions, as well as making unnecessary decisions. A critic of buzzwords and overexcitement around certain tools. Ex-theater actor, 4 espressos a day.
Or more.
So,
Depends on the day.
sounds good. Over to you. Thank you.
Thank you very much. So, welcome everybody. I would like to start with a little bit of, let's say, maybe introducing myself is not that much important, but this year I've started a blog, so you can take a look at one blog post that I managed to write. So I hope it's going to be a little more in the meantime. So one more thing, if you happen to be on any kind of JavaScript conferences in Poland or Europe, I hope to meet you there and talk a little bit. Also, if you are interested in, let's say, getting help or kind of trainings or consultancy in any kind of JavaScript or TypeScript or framework-related stuff like React, Angular, etc., you can always contact me. This is my Twitter. I write about technology a lot, and that's all about me. And let's start with speaking about functional composition with static types. So there are 2 things that I would like to talk about. The first one, the first thing, first and foremost, can you see the font size here? Because this is going to be a purely live coding session. Is the font size good enough? Not that much. All right. Is it better now, or should I make it even bigger? It was. All right. So the question to the people at the end, is it okay now, or should I make it even bigger? All right. All right. All right. Yeah, that was another thing. Okay. So, is this better? All right. Dark default. Okay. Is this one okay? Okay. Is anybody unhappy with this? That's better. All right. So this is going to be a purely live coding session. So not sure if any of you have tried live coding in front of so many wonderful people. It's pretty stressful. So I need to pray a little bit to the gods of live coding. So just a little bit of prayers. Live coding gods, please be with me. Or maybe let's make it more entertaining. Don't be stupid bastards. And to make it slightly more compelling, yep. And just the last step. Okay. Now it should be fine. Okay, so let's start doing the stuff. So we're going to speak about functional composition. That's one of the topics, and static typing. That's another topic, and we would like to combine them. What is going to be different in my talk comparing to Józef's is that we're going to dive deep into, let's say, technical details of how very small pieces work and how we can leverage what is, let's say, working in TypeScript out of the box. And we are going to see some of the limitations of TypeScript and what we can do about it to make it work as we intend to. So this is a small snippet of code that I'm going to publish as a gist at the end of the presentation. I have created a small, let's say, database or a small, let's say, snippet of the data I would like to use. So this is basically a JSON file. There is an array, a big array of over 1,000 of random JSONs, and each of them looks something like, or maybe I can just open it, looks something like this. It's just a developer. Let's say we're working on a project for a big enterprise company that is basically a software house. I'm not going to say any names of the companies like this, but you can imagine. Lots of developers working in different projects. They have skills like this one, etc., etc. So there is nationality, which can be, let's say, United States, Kingdom, France, etc., etc. They might work as contractors or as permanent employees, blah, 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 blah. We're going to basically use it for data processing on various kinds of topics. If you have any ideas, I'll be happy to implement them. So that's just an example. And here we're importing the developer type. Here we are loading the data set. This is just the nationality. Maybe we would import more string literals, and basically that's the setup. And now I'm going to use Now I'm going to use npm start just to execute TS node so that we can just see the output immediately. So whatever we console log, we can see it on the fly. All right. So before we talk about what is functional composition, let's define what is composition. We don't have so much time to do, kind of workshop here to answer all the questions together, although I would love to. But composition is basically when we have small pieces that we would like to connect them together so that they form a bigger piece. This bigger piece could be connected with another piece so that it forms even bigger piece, and so on and so on. We can have object composition, module composition, and finally functional composition. So basically the idea is that we would have lots of very small functions that we tie together. We don't modify them. We don't, let's say, add anything to them. We just wrap them or decorate them so that we build bigger and bigger and bigger pieces. And now the question is how to do functional composition so that we don't lose type safety in TypeScript. We're going to speak and develop basically two types of functional composition. The first one is going to be, let's say, I call it jumping from a given signature into the same signature. This is something that you might see in libraries like Ramda. By the way, what we're going to do is not necessarily something you would do yourself, because you can find it in libraries, or if something is very, let's say, specific to your project, you might need such thing. But this is this is what we're going to do is how do libraries like Lambda or RxJS or Redux work. So it's basically going to be the functional programming paradigm. So that's the one that not so many people are aware of. And the second one is going to be what Józef mentioned in the previous talk. So basically we're going to implement pipe or compose. Basically that's the same thing. Pipe is going, the convention is that pipe is going left to right and compose is just going right to left, but basically that's the same idea. And we're going to do it right. All right, so let's define that there is a function. We would like to define a function to see if a developer is, let's say, if a developer is rich. All this data has salary property in a range of from 1,000 of a given currency, whatever it is, to 10,000. So basically, let's say that if a developer earns more than 8,000, it's considered to be he or she is considered to be rich. So const earns a lot is when we have a D for developer. This is something that is very, I hope, easy for us, right? So it's going to be salary, and this returns salary is bigger than 800. Just let's make sure that we're going to see devs. This is our collection filter. Earns a lot, and let's check what is the length. So basically the length of the original is over 1,000, and let's see what is the size of this one. So we're going to have the second console log. All right, so it seems that it's doing the right thing. So what we want to do is basically to compose multiple conditions so that we can have, let's say, that a developer earns a lot, or that a developer is Polish, or that a developer knows JavaScript. This is the first step. So basically we're going to write very small functions, and then we want to tie them together so that a developer meets all the conditions, and we're going to represent it as a function which will have the same signature. So this is why I say that it's jumping from one signature to another one. So let's say const knows JavaScript. It's going to be for D of developer. That is D skills and includes. These are just strings in this array. So it's going to be JavaScript. So we would like to basically, instead of doing this, knows JavaScript, we would like to do this once, because this the complexity and the performance of this one is going to be worse. And if we wanted to, let's say, do something like this, that for given D, we would like to have D and this D. This is working, but this is rubbish, right? We want to get rid of this rubbish because this doesn't scale. If we want to keep on adding all these conditions, or if we have dynamic conditions, either in the backend if we're doing Node.js, or if we have, let's say, checkboxes, or we could basically click dynamically in the interface what are going to be the conditions, we need to define something that will be dynamic. You might need this in the project, you might not, but basically this is how we're going to work on it. So let's define one more. So we have nationality, which might be, for instance, Polish. So we would like to check if somebody is Polish. So we would like to check, maybe not if somebody is Polish, we would like to check if somebody has a given nationality. So const has nationality equals, and now something that lots of developers who are starting working with functional composition or functional programming basically start is that first we have a developer, right? And then we have the nationality. Then we can check if this d.nationality equals n. This is okay if we have a given nationality and a given developer, but this is, from functional perspective, it's not really handy to work with, because we're going to check this nationality, this single nationality, for lots of different developers, right? So this does not really fit because we know the nationality we want to check up front. We know it's going to be Polish, or it might be German or Czech, whatever, but the developer is going to change, right? So this is something we know up front, and this is something that we don't know up front and is going to change. So it's not really convenient for us to have it in the same, let's say, level of the signature. So I would like to first replace it, replace the order. If we were working in a purely functional language, that would be okay. JavaScript is not purely functional language, so we have to do currying manually. So we have to do some dirty magic like this. So we have to basically cut this function into two pieces, so that it's just a closure, right? But I don't want to make it private, like some people say that closures are meant to make stuff private. Sometimes, only sometimes. But what I want to say, what I want to do is basically to do a function that is Polish, has nationality that is PL, and from this point, like, I can just check another. I can just use this another condition, and it's going to be this way. It's going to be a lot more handy, basically, to call the function. Right. So we have earns a lot, knows JavaScript, and is Polish, and we would like to. Let's say we want to recruit some developers. So candidate criteria met. This is going to be one function. So we would like to define that all of following conditions are met, and it's going to be earns a lot. Another one is going to be knows JavaScript, and another one is actually I can remove. Is Polish. I don't need this variable here. I can just define it like this, right? So that has. I can just define a list of all these conditions. As you can see, this is pretty much declarative, and I haven't calculated anything yet. That's the whole idea, because in functional programming, we are delaying the execution. We are doing lazy evaluation, so that we are declaring what are the formulas, how to do it, right? But we don't call it yet. In functional style, we are defining lots of formulas and even more formulas, and at the very end of the program, we are going to turn on the whole beast that is going to just call all the functions internally, right? So it's just like in reactive programming, for instance, in RxJS, we define lots of streams, and there might be, for instance, one subscriber that basically like makes everything alive, right? That is going to be only one function that will call it. Right, so let's define what is this all. First, we need to define the signatures that we've been missing. So it's a very good practice to define signatures. So we want to find a developer, to define a developer condition function. So basically, it's going to be D for developer, and it's going to return a Boolean. You might wonder, why would I write such easy types? If I'm writing very small things, it's not maybe super useful, but if I'm starting to build bigger and bigger and bigger things, this is going to be really useful. Another thing is, this is actually very limited, right? I would like to do something more generic, as mentioned in the previous talk. So basically, it would be better if I did type, let's say, condition function. Condition function, which is going to accept what is the entity or the object that we're going to check, and for t of type t, just return a Boolean. And that's a lot better. If I wanted to declare what is this the developer condition somewhere, I might just declare it this way. That is going to be a condition function applied on a developer. It's really, really good to start with what is the design of your code, to think about what are going to be the signatures that you're going to use, and only then start coding. Right, so sometimes also it's good, I'm going to move it up, sometimes it's also good to define these at the very top, and to check if what I'm doing myself, if it's correct. For these examples, it's not going to be, as I said, super useful, but if I'm doing something more complex, it's a good practice basically to to define what is my intention, what I want to achieve, then when I define the types, I just do the implementation. Or I would like to make sure that what I return from this closure is going to meet the same criteria. All right, so let's define what is this all here. So const all. First of all, what we're going to have? We're going to have multiple conditions. So it's going to accept lots of these functions, but it's not going to be a developer condition function. It's going to be the condition function of whatever it is. Now TypeScript is going to cry that I didn't define the generic type. So we have to, all these generics are going to, let's say, trigger up and up, but that's okay. And now the whole thing, when we're jumping from one signature into another signature, is that if this condition function was accepting t and returning a boolean, if I'm starting with this signature, what I want to return is to finish with the same signature. So basically what I want to return from here is the very same thing, right? That's the whole idea. So what I'm going to return from here is basically, again, for t of type t, I would like to, oh, this one is going to be, of course, an array. So now it doesn't cry. So this is type safe. It's not true, but it's type safe already. So now we have lots of condition functions, whatever the type is, right? Now we need to only check when all of these functions pass for this given entity. This entity, if we're checking a collection, let's say filtering, this t is going to be different for each element of the collection. So we need to check all the conditions for each element of the collection. So there are lots of ways to do this. I know at least 6 of them to do it. So please shout which one is the one you would prefer for us to code. Let's not do a for loop. This is one of the ways. Like we might do it with reduce, of course, find, every, sum, recursion. The one I like the most is actually find. Like all of them make sense, and it's a very good, let's say, exercise, cognitive exercise to find out how to apply them. But basically, if we take find, for instance, the nice thing is that all the conditions are met for this entity if I find any function that does not meet, right? So I'm going to check if there is any function that will fail. If I didn't find them, it's okay. If I found the function, then the whole thing fails. So basically, I'm going to loop over all the functions and find if there is the negation and then negate it back, right? So that's the cool thing. As I said, it's a nice cognitive exercise to try to see how would it look with sum, every, find, reduce, recursion, and so on and so forth. So let's start. This is CFN, so it's a condition function. So for each of the condition functions, I just need to check if the condition function pass, right here. So this thing, CFN of t is going to return a boolean. So I'm checking if there is any of them that fails, basically. If I found any of them, then I'm going to negate it. That's the whole idea. So it's really nice that we don't have to think about, let's say, what is the value of the variable. We just define, we just declare stuff here. And that's basically, that's all, right? And if we take a look, what is this? Then we can see that candidate criteria is a condition of type developer out of the box, right? This is thanks to the fact that we've defined the generic here, and we are jumping from this signature, from multiple instances of this signature, and we're jumping into the very same signature. Similar, we can still call this this thing. So instead of calling it with this garbage, we can just move it here. And this candidate criteria, of course, could be chosen by the user, or it could be defined in the database, and then we could call it in Node.js if we're doing it on the backend side. So let's see how much, oh, not very much of these developers meets the criteria. Right, so that's jumping from one signature into the other. A nice exercise would be to write what is, let's say, or, so there is at least one of the conditions that passes, at least one function, conditional function that passes, or that we are trying to find guys that meet at least, let's say, 3 out of 5 conditions. So nobody has to be really perfect, but it's good enough, then we just hire you, right? But basically what you need to focus on is we're starting with this, and we need to end up with the same thing. In a similar fashion, we can define a type for sorting stuff. So a comparator, basically we can do it for any kind of processing we want. So a comparator function is something that is going to, when we sort, we need to find the order between the two neighbor elements. So for E1 and E2, we need to return what is their order, basically. It's the callback of sort. We don't want it to be any, of course. Basically, if you define an any in your code, then either something is wrong with the typings of your framework, which happens, or basically you're doing it wrong. So let's try to avoid any as possible. The code that I see on a daily basis is that developers use any because they don't know that type inference might do better, or that they can just use generics. So if I don't know what the entity is going to be, what the shape is going to be, just define a generic that is going to be a lot better. By the way, a small question. What's the difference between this and this? Maybe could you pass the mic? I couldn't hear the answer. All right.
So the first one is going to be like the evaluation of the type parameter is going to be deferred to the point when you call the function. You don't have to provide it up front. Is that what you meant?
Yeah, absolutely. So here, and the second one?
Yeah, and in that case you have to provide the type parameter explicitly, otherwise it's going to be like fallback to any.
Yeah, basically I cannot use comparator. I cannot use this if I don't define what is this, let's say type A equals. I cannot use it unless I define this, as you said, up front. That's the thing. But then it becomes strict. If I define what it is, let's say string, then it's, let's say, defined as string forever. And here, on the other hand, for each of the calls, it's going to be different depending on the circumstances that we're calling the thing. So we need to use this one. All right. So we're not going to spend a lot of time here, but another thing that, let's say, if we wanted to define that a developer earns, everything is about money, I tell you, earns more than, let's say this is a comparator function for a developer. Recruitment and everything is about money. So we want to compare D1 and D2. And as you can see, if I define the type here, then this is going to be inferred from the context. That's a technique also to get rid of any. If we subtract the first one from the second one, this is how I try to remember. If we do it, the first one subtract the second one is going to be the ascending order. If we do the second one subtract the first one, it's going to be descending. So if I wanted to define earns less than, what would you say if we just replace this? Do we like it? It's not a big deal, but it's going to be very messy if we do it this way. Also, we would not necessarily like to snapshot it as a separate variable. Instead, what we could do is define const reverse, which is going to accept a comparator function of given type, comparator function of given type t. So for given compare function of type t, because I have to define it, so if I have to define it here, then it propagates here because it's not the type anymore. Now it's for each call of the reverse function, it's going to fill it with the different generic. Right, so for a given function. Now the thing is, we are jumping from a signature into the very same signature. So if comparator function is comparing two different things, then we can just copy this stuff here. And of course, it's not going to be a number, but if we accepted t, and we know t because we know what was the t inside of this function, this is going to infer it this way. So the t is going to be the same. So if we define earns more than, that is of type developer, that is bound to type developer, then passing it here is going to do this. And finally, this is going to be d. So we basically, composition is not about changing what is going on internally. It's about using what is inside and then using it in another way or combining it with something else. So basically, we want to call CFN with E1 and E2, but we want to, basically, how is this comparator function working? It's either a negative number or a positive number, depending what is bigger, what is smaller, what is before, what is after, or 0 means it's basically the same in this order. So it's nothing is earlier or after than the other. So basically, if we have 1, we want to make it -1. If we have -1, we want to make it 1. And that's basically reverse, right? So if we want to have earns less than, so what we would do here, and now we don't need to define the type here, like if we want to be really if we want to have more safety impression about ourselves, we can define the type here, but we can just do reverse of earns more than. So this is one of the ways how to do this first type of composition where we jump from one thing into one signature into the same signature. Let's just make sure that what we're doing here is actually true. So let's sort earns more than, and now we want to check what is the first element, so the guy that earns the least, what is its salary, and it's going to be really small salary. That's like 1000 is the random minimum, and now we can just do, instead of this one, reverse and do this one, and now it's going to be around 10,000, right? So basically the whole array is sorted. Now a question. If I wanted to create, let's say, const combine sort, how would I do this beast? So let's say I would like to sort all of us through nationality, let's say, that there is an order of sorting. Then I would like to sort by, let's say, height, and then by, oh, is it so amazing? So much emotions. Right, so how would we deal with this one? So that I would like, what I want to achieve is I would like to have const, let's say, the order of God. And it's going to be a combined sort of, let's say, earns more than, and then let's say, what do we have here? Any idea? Oh, maybe personal info age is younger than. That's, I hate dealing with dates. I hate it, really. So earns more than, let's define is younger than. And this is younger than is going to be const is younger than equals for D1 of type developer, or maybe we can just copy it from here. If the developer, yeah, so let's sort them that they earn more. If it happens that there are a couple of developers who earn absolutely the same, that I want to check which of them is younger or whatever. Basically, it doesn't matter. But yeah, if they are the same in this order, then we jump into the next order. D1, D2, and now is younger than. So it's going to be is younger. So maybe this one is going to be D2 personal info dot h minus D1 personal info dot h. Right. So we could define it as is older than, and then to reverse it. But basically, you know the idea behind it. So now, what is the idea behind combined sort? Any clue? Like, try to think about what we've done here and what we've done with the all stuff. Like, I would really love to make the font smaller so that we see more code, but it's going to be difficult. Any ideas we have? We have two ways to sort let's say the data set, the same data set. One is that somebody earns more or somebody earns less, whatever, and that somebody is younger or older than another person. So first, money is important, so we sort by money, and then if few people that have absolutely the same salary, let's say they are financially equal, right? Then we want to sort them by age. We're not trying to find the group of developers, because if we have, let's say, here we've got over 1,000 of the developers here, right? So we need to sort them in this combined order. So the major order is this one. If equal, then another one. If equal, then another one. If equal, then another one, and there is a bottom condition at the very end. They might be, theoretically, they might be equal in all cases. Right? So how would we deal with that? Basically, the first thing is we need to define what is the signature again. So we've got that. This is the comparator function. So we're starting with, again, multiple condition functions. Here we've got comparator function that I need to pass this thing, and we need to pass what is t here. Okay, so we've done with the boilerplate. So once we have we've caught what is the what are the criteria, then we can do defs.sort and then basically pass this sort by the order of God here. So this is going to be for E1 and E2 return a number here. So we need to return this comparator function from here again. So again, for E1 and E2 return, and now it's going to be, let's say, 0. Now it's type safe, of course. It's not the thing, but here I can see that TypeScript is not crying about the types yet. Now only the values need to be found in the correct order. So what we need to do here is we're trying to, let's say, if the developers are, let's say, not financially different, that I will finish here. If the developers are financially equal, then I need to go deeper. So I need to execute one more function. If they are equal here, I need to go to another function. So basically, what am I doing here? I'm trying to find the first function, right? That will not have 0. If it's not 0, then I'm just returning what was the result here. And if I don't find the function that would return something different than 0, then, well, they are absolutely equal in all criteria, right? So then I need to return that they are equal. So it's going to be functions. Functions? No. CF comparator functions. All right. CFN find. So I'm trying to find the first function that will do like E1 and E2. Now this is going to, like, this might be difficult. We'll see if we can write it in one line. So basically, const result. We need to see what is going to be the order here. So if we've got CFN, this is the original result. We need to find if this is different than 0, right? So we need to check. So basically, maybe I didn't do what was intended here. Sorry for this one. I'm writing it 100% live. Const result. So we are trying to return 0 just to shut down TypeScript crying. So I'm trying to find the first function that will actually not return a 0. So this one has to be different than 0, right? So that's the thing, right? This is, what is this result going to be here? It's going to be a comparator function, right? So this is the first function that does the thing, right? So if we turn on strict null checks, that we would know that this is either a function or undefined, because find is either returning the item from the collection or it's undefined, right? So now I need to check if so we can just return it here. And since we don't want to do, you know, returns from if statement because that's imperative and ugly, we're already imperative. So if first function is a function, right? So if this is truthy, then we need to return this thing, because that's basically the order, but it's going to be returned from this function. So if this is a function, so it might be, let's say, they're financially equal, but they're not equal, like, let's say, age equal. So if we found the function, then this is either -1 or 1, then we are going to basically return it. This is already executed within sort, so this is going to, let's say, put them in order. But if we didn't find it, if we didn't find the function, so if this is undefined, then they're absolutely equal, which is basically 0, right? But what is important here? What we're returning from here is a comparator function. This is a combined sort. So from this signature, we are finishing with the same signature. So we can sort it like this. We can add the reverse here, whatever. And this is nice and declarative. And we want to sort it. I don't know what is going to be the salary here, but let's check it out. All right. So earns more than. Oh, well, it actually makes sense here. So let's say, what is the reverse? Maybe it's not easy to spot it from from an eye. What is going to be the result? Let's swap them. So now we are expecting. It's the salary. So let's check the age here. Dot personal info dot age. Yep, seems like it's doing or maybe I messed up the order. As I said, live coding is not the best form of presentation you might give. All right, so we've got that. So this basically covers the first part, which was the longer one. So jumping from a given signature into a different signature. Basically, you could do whatever kind of processing you would like here. What is important to define the signatures and then to return the same signature from whatever composition you might do, right? In object-oriented programming, the pattern that does absolutely the same, it's called a composite. And it's basically, well, very often in object-oriented programming and in functional programming, there are the same patterns. They might be called in a different way, or what we have in in object-oriented does have a name, like command or a strategy, and in functional programming, it's just a function, so it just doesn't have a name. But we have absolutely the same patterns. The same thing is what I would like to do with the pipe. Not sure if we do have still some time to implement the pipe, but what we want to do, let's say we would like to get the Easter bonus for all the developers. So for a given group of developers, I would like to apply some conditions, whether they're Polish, whether they earn some, let's say, some money, the criteria. So I would like to do the pipe, the same pipe that Józef was speaking about in the previous presentation. So there would be, let's say, the first one, filter by what we've got there, earns a lot. So let's define earns crap, and it's going to be, let's say, less than 2,000. All right, earns crap. It defines the situation pretty well. So let's filter the guys who earns crap. Then once we have the guys who earns crap, we want to filter who is Polish. So of course I'm going to get lots of TypeScript errors here, but this is very declarative. And another thing, if I was writing in an imperative, like why would I write this way? One situation is that I'm using RxJS and the framework forces me to do it, so I have no other solution. Another reason why I would like to write it this way is that I would not like to define a separate function for this that would be, let's say, devs.filter, there is condition 1, and there is another condition 2, and then some reducing, some mapping, blah, blah, blah. Wrap this in one function, let's say function, some big function 1. Right. So for devs, do this stuff, whatever it is. Right. So for one combination, I've got one function. For another combination, I've got a second function, and so on and so forth. I don't want to copy this, right? First of all, I would like to have this dynamic if this is my requirement from the application, and I don't want to create a separate function that would have to be separately tested, right? I would like to test only the small functions to test the composition itself, and then automatically, if all of these are correct, then automatically any type of any combination of these composing functions is also going to be correct. Right. So if something is filters is crap and is Polish, let's say that we can do all from earns crap and is Polish here to make less filtering, or even or we can or has nationality of Polish. PL. If we're not happy with what is going on here, we can just split it like this. So the first step is going to be the filter. The second step is going to be, let's say, get what is going to be the total, let's say, 25% of the salary. So let's say 25% of the salary. Let's define it later, and then the last thing is going to be basically the easiest reduce possible. It's just going to be a sum. So after we have filtered the developers who meet the conditions, we're going to help poor Polish developers, then take 25% of their salaries, sum them together, and know how much all this Easter bonus is going to cost us. And we don't want to do it in this context in a prototype fashion. We want to do it in the functional composition fashion. So we're going to stumble upon a few TypeScript limitations here. So let's start. Pipe. It's going to be basically a function that will accept many functions. We don't know much about these functions, so we can start with function array. It's very, very rare that we should use this function because we don't know pretty much nothing about what the function is, right? But this is, let's say, we could make it slightly more detailed, but let's stay with this function here. So we're starting with this function, and now, how is this thing going to work? We want to do lazy evaluation, so we don't pass the developers yet. We will pass the developers only here, console.log. This is going to be bonus. And here goes, what is the Easter bonus of our developers, whatever the group is. So we define the formula, and only at the very end we are going to evaluate it. 25% of the salary is not going to have any kind of parentheses here. So get Easter bonus, pipe, is not going to return the value, it's going to return absolutely the function, right? So what it's going to do, this function, it's going to accept the input of the first function. The result of the first function is going to be passed as input to the second function. The output of the second function is going to be passed as input to the third function, and so on and so forth. And finally, the result of the last function is going to be result of pipe. So we're not the result of pipe is the function that will accept what is the input value here. So we need to accept the value. The question is, what is this value? We don't know yet, and we're not going to define any t here because it's not going to work. But if you want to, let's say, pass this initial value, which would be the initial value here, How are we going to do this? The easiest way is to use reduce, absolutely. So left to right, we are starting with. So in order not to mess up with anything, always we have an accumulator and an item. We return the accumulator and we start with the init one. I'm trying to write this like like a monkey, so that I just write the boilerplate, and only after a while I'm trying to actually start to think, what is this? So what are we going to start with? The initial value is absolutely the value. The item that we are going to iterate over is just another function. What is our accumulator? The thing that we start with is the current value, whatever it is, this current thing that we are going to pass from a step to another step. So it's going to be, let's say, a current value, whatever it is. And the result, the only difficult thing is just calling. What is the result of calling this function that we have in this loop iteration with current? And that's the whole thing. This is nice, but it's absolutely type unsafe. So we've got rubbish, and if we call it like this, then we have for some functions, we return a function that for rubbish returns rubbish. The problem is, and here we come to the limitation of TypeScript, is if we have a collection of absolutely the same things, by the same things I mean the things of the same types, then we could define what is this function, and then type inference would work automatically. The thing is, the first function might have one signature, the second function might have completely different signature, and the last function might have a different signature, yet different. TypeScript does not handle it automatically, but all is not lost, as in the meetup announcement. We can help TypeScript a little bit. So we can we don't have function overriding in TypeScript, because if we've had multiple implementations of the same function, then the last one would override all the previous ones. But we can override the signatures of the functions, but we can only do this using the standard function keywords. So we have to roll back to function pipe and to go to this dirty parentheses and return. So we've had to roll back to this crap, and now we're writing. Now we want to, what we're going to do here is, we're not going to care about defining what is here, because basically there is no way to define what is going to be the combination for 2 functions, or for 3 functions, or for 4 functions, 5, and so on and so forth. And RxJS pipe is doing this trick, Lambda compose and pipe is doing the same trick, Redux compose is doing the same trick, and so on and so forth. And you will see cascade of something that we're going to write here. And this is basically the pipe that is going to work correctly. We will see it in a while. It's not going to look nice, but the nice thing, we're going to benefit from it, but it will look very ugly. And we don't have to write it on our own. Framework authors have to write this boilerplate. So basically, we have a pipe that we've got a function f and a function g. Of course, it's not going to be a function and a function. Now we want to become more precise. So the first function, let's say that calling a pipe with one function does not make any sense, so at least 2. So instead of having a function and a different function, let's define that the first function is going to accept t, that is of type t, and return u, just go along with the alphabet. We don't know what is t and u, so we need to define them here as generics, and they're going to be different for each call. So this is the first function. So the return type of the first function is going to be the input type of the second function. So for u of type u, we're going to return v. So if we, of course, v is also going to be the generic. And what we're returning is that for the input of the first one, we're returning the a function. That for input of the first one, we're returning the output of the last one. So basically, the input of the first one is t, and the output of the last one is v. But it's going to be a function again. So for t, let's return v. Now, this is ugly, so let's make it slightly less ugly. It doesn't help much, but at least it's readable at some point, right? Right, so this is one case. The second case is, and now we're opening a beer, FGH for V of type V, return W, and you can find a lot of these. And now the question is, how much patient is the author of the framework, and how far is he or she going to go on with this? So we're returning for type T, let's return W. If you walk into the sources of libraries, like all these functional composition stuff, you're going to see absolutely the same stuff. T, U, W, V, W, X, right? X. So for W of type W, let's return X, and here it's going to be X, FGHI, and so on and so forth. I'm not going to carry on. Like, usually the patience is around 7 or 8 functions. I don't know if you have seen Anders Helsberg, the author of TypeScript, talk. If we define a tree structure, that basically a definition that its children are of exactly the same type. I don't know this stuff because it's really very advanced, but it's supposed to be very difficult to do it in an infinite way. So basically, they assume that nobody is going to do anything within TypeScript code deeper than 5 levels. So then they just cut it. So that's a similar, let's say, limitation. If somebody is complaining about this, then raising an issue, and they will just add a couple of more of these, just trying to satisfy the person. All right, so we've got the pipe here, and here we've got +2 overloads. I think you have seen such situation, or +11 overloads or something like this. The thing is, this is very, like, basing on how many of these functions we pass here, this is going to be very dynamic. But the question is, what is going to be the type T that we start with? We didn't define what is type T here. But before we see what is going to happen, let's define a couple of functions. Like, we could do that for devs, do devs.filter, blah, blah, blah. Let's define what is filter. This is called pointless or point-free programming. So filter is for a given collection of type T array, return collection dot filter. So we want to get rid of this prototype, so we are basically hiding it, right? If you don't want to show it, you just hide it. But we're not going to start with this thing. We need to start with the filtering function. So that was our condition function. What was the name? Condition function? No, comparator condition function should be it. Condition. All right. CFN of type condition function of type T. Now it's going to work if we pass this. So now we just forget that and everything. Like, basically, it's a closure again. So we basically want to get rid. Like, we want to make it shorter, right? It would be perfect if we defined filter using a pure reduce, and a pure reduce, this would be the only, absolutely the only thing that would be anyhow imperative, right? Reduce itself. Basically, filter, map, find, for each, blah, 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 all of these can be defined with reduce. We don't have time for that, but we have filter, filter collection. All right. So, and I have a problem here. Parentheses at some level. Yep. Thank you very much. So we've got developer here. All right. Okay. So if I define that this is going to be a developer, that it has already the input that it is going to be a developer, but if I'm a, okay, we support 4 functions, so I can add 1 more. If I'm a dirty bastard, and for a given, and I define something more, that for a given collection, let's define that it's going to be collection.filter, that for anything return true. I don't know collection.filter. All right, we've got that. So we don't know what this collection is going to be, but what the hell is this object, right? Have you stumbled upon a situation like this? we have generics automatically, and when we don't pass the generic, it's going to be automatically evaluated as an object, and some people are pretty unhappy about this, and this is a funny meme that somebody made. One cannot, oh sorry, I'm going to open it once more. Oh shit. One cannot simply resolve unspecified parameters by an object, but that's basically how it works. So if you find that there is an object, what the hell, internally, then it means that we need to define, in the first function, we need to define what is the input. So once we've got that, it's a developer, we know it from here. These do carry the information of the developer, so all carries the information about the developer. So now filter also carries the information about the developer, right? Then we can proceed further. So 25% of the salary. So now this is going to be a mapper. So for devs, we want to basically map it, right? So for a given dev, give me d.salary, and as you can see, I've got type inference all over the functions, though I don't define anything here, right? d.salary divided by 4, so I've got 25%. So what I've got here, the sum, this is going to be a simple reducer that is going to accept what is the, again, accumulator item and the accumulator at the very end. So what is going to be our item? Our, oh sorry, we don't have the reducer, so we need to do for amounts. Let's do amounts dot reduce, and let's wrap it with the parentheses, and now it's going to be okay. So for amounts that are a list of numbers, an item is just going to be a number, our accumulator is going to be the sum, and what we got here is sum plus n, and we've got numbers array, and only these functions do carry information that they are developer specific. As you can see, these don't, but everything is passed further. So the whole, let's say, result of get Easter bonus is for list of developers is going to be a number. So let's finally, okay, we've got all the code, so let's calculate it. Let's see. Oh, it's pretty much, let's say, 20,000. And basically, that's it. That's all I've got for today. Don't want to keep you longer. Thank you very much.
Do you have any questions? Anyone?
Okay, I do have one. Okay, so first thing, I wanted to say this was really, really good talk.
Thank you.
And you can see the theatrical experience. Most speakers are such nerds, me included. So, well done. I wanted to ask about condition function.
Yep.
Did you avoid the word predicate on purpose to be understood easier?
First of all, I try not to learn things by heart, so I had my notes here, but I didn't use them. So everything I wrote here was just out of my memory. 50-50. Sometimes I use the word condition, sometimes I use the word predicate, and it's like sometimes I just use this, and sometimes I use that one. Sometimes during my trainings, let's say the attendees think a better name in some certain situations. So no, there is absolutely no reason that I choose this name. No, it's the same as, absolutely the same. Basically, it's going to check if a condition is met. It should be a sentence, right, that evaluates either to true or to false. A Boolean sentence.
Yeah.
No reason for this.
So, thank you. Maybe instead of doing all of these overloads, I believe there is a pipe typed recursively in a library called TypePark. It worked last time when I checked, but actually that's more code than this, so this is probably the best way.
Okay, first of all, TypeScript is growing hugely, and there is a lot of improvements here. So it might happen that if anybody is watching this talk, let's say a year after today or 2 years, then this might not be true, right? So I hope that at some point, but basically the problem here is that there is no syntax to define how to do this, right? What Angular would do would be, and this does the job, right? This would be the Angular way to do stuff. Or maybe it would be even, let's say, some kind of magical string literals. But maybe the problem is that there needs to be some kind of syntax to define how to wrap into an array, into a collection, things that are of completely different types, and how to get into the types. There is no syntax to do it. But if you take a look into Rx, Lambda, Redux, you're going to see this as a one-liner. It's going to look more like this. Let's see if yeah, what they call like Doom something. It's going to look like this, but it's just going to a pyramid of Doom, whatever. This is how it's going to look. Maybe what you're saying is basically even more generic way to do this, and then the result has this behavior.
Tuples can be typed. You can get a type for head and for last, and you can do many ugly hacks. But yeah, that's probably the production way to do it. Okay, does anybody?
Yeah.
Thank you.
Thank you.
Any more questions? Anyone?
Come on, don't be shy.
So you use this function way of overloading. Is it intentional? Do you know of the other two ways, or does it not work for this case?
What do you mean the other two ways?
By the type and by the interface. The way, for example, React Connect does it.
I'm not sure if I'm familiar with the type definitions for React Connect or if I React Redux Connect. So I would need to check them up front before I answer you. Like there are too many tools to remember all of them at the same time. So we can take a look at them and chat with a beer.
Yeah.
In a while. Maybe I do know them, but I just didn't recognize them by the name. JavaScript is, you know, it's impossible to remember everything.
Another question. Up there you have const variable name :type equals, let's say, a function that takes an argument of type. So that's a kind of, do you do it intentional, or was it just?
Can you tell me where?
It's up.
Okay.
So for example, developer condition function equals the of type developer. So you don't. It's
this line
23. You don't really have to say the :developer. Is it just because of the live coding? Or
you mean this part?
Yeah. So
okay. So it's very subjective. Every person could do it in a completely different way. My way of doing stuff is if I have, let's say, a function that will sum numbers, then I might not do this stuff because it's just too easy. But when I start doing functions, I think about, or any code, it might be object-oriented as well. I think about what I want to achieve. So I want to define my intention in functional style. I define my intention as a signature. So let's say I do a function that
I understand that. My question is just, do you do daily like?
Sometimes I leave it. Sometimes I delete it because this is going to be inferred. But the thing is, we don't work alone. And the more, you need to find the golden middle, right? If I leave it like this, it's more verbose, right? There is more to read. But on the other hand, if somebody is less experienced, then if I leave this stuff, okay, it's more verbose, but maybe for somebody it's going to be easier to read. So I always start with this thing just to make sure that my implementation meets my intention, right? Because I check myself, or maybe I declare my intention, and I make TypeScript validate my implementation against my intention. That's what I do. And sometimes I drop it, sometimes I leave it. But yeah, sometimes I drop it, absolutely. That's not needed because it's type inferred, absolutely.
I was more asking about dropping the colon part rather than the
the
first
colon.
one.
All right.
Because it's like a duplication of the type.
Ah, of course, it's a duplication. So you mean that having this,
Yeah, I was just asking if
I
you do
I
it
can
like
remove this.
on a regular basis.
It strongly depends if I'm working with people that are familiar with TypeScript and know what they're doing or not. If I would be working with, let's say, seniors who are very new to TypeScript and they are TypeScript juniors, then I would rather be more verbose. If I would be working with people that are more, let's say, feel more free with TS, then I would rely on type inference a lot more. But basically, this talk, it's not only about composition itself, but it's also about inference, right?
Yeah, yeah.
So as you can see here, so to answer your question, in this part, I did not concentrate on removing the useless, the redundant types. I didn't concentrate on removing the redundancy, but at the end, and that was my impression, that was my goal. Here there are no types absolutely, right?
Yeah.
So that was like, we're not defining that for an array of developers, blah blah blah. We're not doing it, right? So yeah, but it depends. Like whatever works is okay, and the quality and the time you deliver it, just find the gold middle.
Yeah, it was very good talk, by the way. Thank you.
Thank you very much.
Okay, I guess that's all to finish. Thank you very much
Thank you.
once again.